So folks, in this video we want to look at, or in this pre-work, we want to look at eventually solving what are called rational inequalities. That is, we want to learn how to solve inequalities like this. Notice that we have the less than or equal to sign here. Or we might look at other inequalities like these in this example. But before we do that, I want to make sure that we're okay to go with a lot of the prerequisite skills. So I'd like you to go ahead and work questions 1 and 2. Those are review questions and they have solutions for them. So pause the video, work questions 1 and 2 on your own. Okay. The next thing I want to do is I want to go ahead and add these two. Notice this is still not an inequality. This is still an equation, so this is still in a sense a review from earlier problems. I want to go ahead and add these two or I want to solve this expression for x by combining fractions. Okay. So this is how a lot of people like to solve this equation here. And there's nothing wrong with solving it this way for this problem, but as problems get larger, this method becomes a little bit less helpful. Off to the other side, we can identify the LCD as x minus 3 times x plus 4. And so we could go ahead and multiply this expression by any factors missing from the LCD over themselves. This gives me, for the first fraction, x plus 4 all over x minus 3 times x plus 4 plus x minus 3 all over x minus 3 times x plus 4. And now we have two fractions with a common denominator. Careful, I don't want to divide out these common factors because I just introduced them there so I could add these two fractions together. This is what I call muscling your way through the fractions. And it's not bad to do this, but in other problems it won't be quite as helpful if we do this combine the two fractions together step. We'll see a better way to do it in just a second. So this gives me 2x plus 1 all over the common denominator has to equal 0. And then what do? What we do is we go ahead and say, and I didn't give myself quite enough room here, folks, I'm sorry. I should have written a little bit smaller. But we go ahead and tell ourselves, well, when is a fraction equal to 0? So as messy as this is, notice that this whole expression on the left-hand side is just a fraction, and we're asking when is it equal to 0? Well, a fraction is equal to 0 only when the numerator is equal to 0. So if we set 2x plus 1 equal to 0, this gives us the sole solution to this problem. 2x is equal to negative 1, or x is equal to minus 1/2. Okay. This is the way students are usually most comfortable with solving these rational equations. What we did was we went ahead and we multiplied both of the fractions by the missing factors from the common denominator so that we got a common denominator and then we added them together. This is a method that I'm going to discourage you from using in this problem. And instead, the method that I'm going to encourage you to use is to solve by eliminating the fractions. So we look over 1 over x minus 3 plus 1 over x plus 4 equals 0. I'm going to again identify the LCD. But this time, instead of writing these two fractions in terms of the LCD, I'm just going to multiply the LCD to both sides of this equation. So here we have the LCD being multiplied to the left-hand side and the LCD being multiplied to the right-hand side. Now watch what happens when I distribute the LCD to both terms on the left-hand side. When I distribute the x minus 3 times x plus 4 to the first fraction, this factor right here and this factor right here divide out. So I'm multiplying 1 by x minus 3, and then I'm dividing 1 by x minus 3. Those divide out. And so I'm just left with the x plus 4 times 1 for that first term. For the second term, similarly, when I distribute the x minus 3 times x plus 4, that LCD, to the second fraction, the factors of x plus 4 divide out, and I'm just left with x minus 3 times 1. And on the right-hand side, we multiplied the LCD, but we multiplied it to 0, so we just ended up with 0. And what I want to point out here, folks, is notice that in one step, by multiplying both sides of the equation by the LCD, I've eliminated fractions from this problem in one step. Whereas in the traditional way of solving this problem, I had to continue to work with fractions through many different steps of this problem, inviting more opportunity for error. So I'm going to encourage you to solve this problem by eliminating fractions rather than by combining fractions. I call that muscling your way through, getting common denominators and combining terms. So I'm left with, in this equation here, just to show you that they're equivalent, I'm left with x plus 4 plus x minus 3 equals 0. And so again, I get 2x plus 1 is equal to 0. Or again, we end up with x is equal to minus 1/2. So of course, if two different ways of solving an equation are valid, we got the same answer either way. And I would argue that this is a faster, better way to do it. If you find this way difficult, folks, I would love to have a one-on-one chat with you or just a brief conversation before or after class or in office hours so I can convince you of what I'm doing here and why it's a better way and will serve you better when you get to calculus. Okay, folks, that was our review. Hopefully you worked these two problems on your own, and we did this review of combining fractions. When we come back, we're going to jump into the main event of this pre-work, which is to solve inequalities. So I'll see you in the next video. Bye-bye.